This video, we're going to look at how to find the vertex of a parabola. Well, when it's in vertex form, it's pretty straightforward. It's given to you. It is simply the point HK, remembering that this will be the opposite of the way it appears because it's x minus h. And this will be what it appears because it's plus k. So just remember that little detail, but it is the point HK. Finding the vertex of a parabola in ax squared plus bx plus c is not as simple and straightforward. So when you look at the vertex of a parabola in this form, it helps to understand a few things to make sense of how we actually calculate that. So if you recall, from quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And these two zeros right here are these 2 points, negative b plus the square root over 2a, and I'm just going to yada yada, and negative b minus the square root all over 2a. So what I want to point out here is that there's symmetry. There's a very specific symmetry. And the symmetry is over this, we call this the line axis of symmetry, the axis of symmetry there. But you'll notice that points on a parabola are equally distant when they have the same y value. It is perfectly mirror image over this axis of symmetry, that line in the middle there. What that means is if we know our zeros, those are the two zeros, x equals negative b plus square root and x equals negative b minus square root, we can actually know where that line of symmetry is, that axis of symmetry. And we find that by simply finding the middle of those two symmetrical points. And if you remember midpoints, how to find the midpoints, finding the midpoint is simply averaging those two values. And so we're going to average those two values. Literally add them together and divide by 2. Well, these are the two values. That's one and that's the other. When we add these together, something kind of cool happens. Because we have negative b plus the square root and negative b minus the square roots, those square roots will actually neatly go away when I add these together. So what I have is negative b over 2a and negative b over 2a, and once again the square roots go away, and so I have 2 negative b's over 2a. Remember, when you add fractions, the denominator doesn't change. And so when I add the 2 points together, I get this. And so I get negative 2b over 2a all over 2. Well, we have a 2 on top and a 2 on bottom in this fraction right here. So those simplify out, which means this really just becomes negative b over a over 2. This is visually confusing. It's weird to have fractions inside of fractions. So we have the piece on top, which is a fraction, divided by 2. Well, remember your dividing fraction rules. Dividing fractions is flip a second number and multiply. So if I write this as negative b over a divided by 2, the multiplicative inverse of 2 is 1/2, which means we could rewrite this as times 1/2, which gives me negative b over 2a. Now this negative b over 2a, that is the axis of symmetry, that is that mirror image. Now why does that matter? It matters because the vertex is on the axis of symmetry. In fact, it has that same x coordinate. So let's see here. The x equals negative b over 2a. It is the x coordinate. It is the x coordinate of the vertex. It is the x coordinate of the vertex. So when I look at this right here, this vertex can be found by saying what is negative b over 2a. And that'll give me the x coordinate of that vertex. So it's literally just negative b over 2a. Now, the question then is, because the vertex is a point, is x comma y, what is the y value? Well, as it turns out, you can find the y value by simply plugging the x value back into the function. So let's do a quick example to make sense of this. So if I have x squared, so if f of x, my function is x squared plus 6x plus 13. And I want to know where is the vertex of this parabola. So if I think about A, B, and C, which I guess we don't need C for our formula, x equals negative b over 2a, but A is 1 for this case, B is 6, and C is 13. So when I look at negative b over 2a, so that is negative of 6 over 2 times 1, that gives me negative 6 over 2, which means the x-coordinate of the vertex for this parabola is negative 3. So I know that it's negative 3 comma something. To figure out that something, we actually need to plug negative 3 back in there and there to figure out what is the output when x is negative 3. So we go to plug that in, and I have negative 3 squared plus 6 times negative 3 plus 13. Negative 3 squared is 9 plus negative 18 plus 13. And when I clean all that up, I get 4. So the y value is 4. So my vertex for the function x squared plus 6x plus 13 for that particular parabola is negative 3, 4. So you can find the vertex of any parabola either by completing the square and putting it in vertex form. Oops, I went too far. Putting it in vertex form right there. Or you can simply use this formula right here, x equals negative b over 2a, to find the x value of the vertex, and then plug it in to the original function to find the y value of the vertex.